Hey everybody, this is Larry. This is me going with Q4 of the bi-weekly contest 118. Find maximum non-decreasing array length. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. So this one was very hard. I didn't solve it during the contest. I feel kind of sad about it. There are a couple of reasons, and we'll go over a lot of these reasons, during this video. And if you are just watching the beginning, let me, this video is not going to be 3 hours long or whatever, or maybe the video is, but the explanation is going to be much shorter, but hopefully detailed enough that it's not that short. It's shorter. It's just that I wanted to show my process of how I learn throughout the process, and show you while I'm learning. So that part you could probably skip or skip ahead or whatever you need to do, but I just wanted to give it to you so that because I think one of my things that one of my pet, and I wouldn't say pet peeve, but one of the things that why I have this channel is because I always people make these videos of how everything is perfect, like all these things of all these perfect conditions, and this is how you do it, obviously. And and it's easy when you know the answer. But what I try to do is also show people the hard parts, right? The learning part, the trying to understand part, and the grinding and the implementation, and me even making silly mistakes even after kind of maybe understanding, and a couple of times even yeah, a couple of times even like thinking that I got it but then didn't. Yeah. Anyway, so this one, the core part is going to be dynamic programming. I mean, I think so. If you watch enough of my videos, you know that what I talk about a lot is this idea of asymmetry, right? And this idea that for some problems, going forward is not the same as going backwards, and so forth. For this particular problem, that's not the case for that thing. But there's another asymmetry here, which is that the way to write pull is not the same way to write push. But first, what I mean by that, first we'll do something more naive. Let me try to go over let me put up the paintbrush. Sorry. Let me try to go over the more naive dynamic programming solution first, right? So basically, here you have some so let's just say you have a lot of numbers. Can I copy and paste numbers into this? Nope. Okay, fine. I mean, it doesn't really matter, right? So I'm using my finger and the touchpad, so it's very hard to do it. But yeah, let's just say we have a sub 1, a sub 2. Okay, fine. I give up on a drawing pad. Let's just use ASCII art. Sorry, friends, my drawing is a little tough. But yeah. But yeah, basically, let's say you have a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, right? And, and this is a longest path in a DAG problem. You could formalize that as a longest path in a DAG. And what that looks like would, if this wasn't if this was the easier version of this problem, and n is not 10 to the 5th, but n is something smaller, like say 1,000, this would be pretty, I wouldn't say it's trivial, but it is more straightforward, right? Because basically, and it doesn't make it easy, but it is more understandable, is that you can think about nodes as the space between the things, right? And then the idea is that, you draw edges between them if certain conditions hold, right? And then now you're trying to go the longest path in the DAG, going from left to right. Yeah, I mean, that's basically the idea or the visualization. Of course, you can do this in n cubed, you could do this in n squared. There are a couple of ways to do it, right? And the way that there are a couple of things that I tried to do during the contest, but it just didn't work out. and you could watch them. I don't even think it's worth exploring because I just kind of, it was not quite on the right track. I had a couple of ideas that were on the right track, but I just couldn't. And even like after I quote unquote understood it, you'll see later in the live portion, this is where the asymmetry puts in, right? So the idea that I had was that the couple of observation is that when you add that you could solve the sub problems from left to right, and what I mean by that is that yeah, so the solution for this one from the solution for A1, A2, A3, A4, A5 is a function of the solution from A1, A2, A3, A4, which is a solution, something like this, right, with some states. So your recursion will look like this if you do it recursively, but the idea is kind of just pre-calculating, maybe not even pre-calculating, but calculating the edges in a way, right? Because the way that I am very good at, and this is just me, you could define the definition of very good, but it's fine. But the way that I would say is that there are two types of ways to kind of write a certain type of DP. It's called some are easier to write with push and some are easy to write with pull, right? And the idea, and what does that mean, right? So push, I'm going to give a very, very quick thing, right? Push DP, I think, is, so pull DP is the one that I'm more familiar with. I don't know if I said the right thing already. But basically, it's just you go to, for example, now, let's say we have x, or we have to calculate some f of x. We get f of x by looking at all the edges connecting to x and picking one, right? So that is f of x. That is pull DP. I mean, I'm hand wavy a little bit, but bear with me for a second. And then push DP is when you. This is when we process. So push DP is when processing x. F of x is already finished. Update all edges. I'll go, update all. Let me rewrite. Look at all edges. Look at all the. Let me rewrite this. Look at all the edges of completed nodes and picking one, right? Remember that for dynamic programming to work, it has to be a DAG. And so you think about it this way, f of x is pulling from things that are done, right? And push DP is, okay, now that f of x is done, let me update all the things that needs me, right? So yeah, update all nodes that needs f of x, right? So yeah, look at all completed nodes and picking one, maybe connected to f of x, right? All completed nodes that fx needs. And I think in general, pull DP is easier for me to kind of comprehend. Like I said, that's the part that I'm kind of better at. But this one, it turns out that it's much easier to write push DP because of the way that we process stuff. But even on top of that, there are a couple of things that we have to kind of not proof, but kind of to go over in a way because of greedy, right? So I think it makes it kind of tricky. There are a couple of greedy things is that from here, one idea to note is that from here going from I don't know any sub problem to a bigger problem. I have a bigger problem, but you can always just have the same number of not segments, what do they call it? Array length. Because you can always just say whatever the answer this is. Let's say you have this is the answer. You know, some I don't know how to write this. But yeah, but basically the idea is that you can always add A4 to A3, so then now your new answer is going to be A1, A2, A3 plus A4, or whatever the rest of the answer is, right? Dot, 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 right? On the last number. So you can always, there's always an answer. You'll never be stuck in a way such that, you know, you don't have a previous answer, right? So that's one. And for this particular problem, there's actually a combination of pull and push, which is why this is actually a little bit tricky, at least for me. But the push part is the part that I had issue with, though. Yeah. So that's part one, is that you can always extend from a previous subproblem. You get the same answer, you won't make the answer bigger, but you know, it is possible. And yeah, and I think that's, and then the other part is a greedy kind of thing, right? Meaning, okay, so let's say you're able to get a length of two of the same length. You obviously want the last sum to be the smallest as possible. I think this part makes sense, right? If you could get an array of length 3 by combining it to a length of length 3, you want the last number to be smaller, so that in the future, in a greedy kind of way, you can take advantage of more possibilities. So that's 2, and that's basically the idea behind this problem. I think the part that I think, so for me during the contest, I did think about, though I don't know that I went over it too much, like, because for me, I just couldn't process. I couldn't figure out how to do it correctly. Is that I was doing pull, but I just couldn't get the complexity to work out. And I did try other things, but yeah. But push DP in this case then is yeah, it's what we need. So okay, so let's go over the code. You could actually write this in a number of ways. I don't know why I did previous, but I guess I needed it for this. But yeah, but basically the idea for the DP is, well, one is that we use prefix sum. The idea behind prefix sum is so that we can get any sub-array sum in all of one time. I'm not going to go over this one in this video because it probably is going to be a little bit long, to be frank, even the explanation. Because, I talked about it a lot in other problems, so definitely find another prefix sum problem and I'll go over it a little bit. But the idea is just that you can get a subsegment sum in all of one time, right? And basically, okay, so here, let's go over the code for the DP. But yeah, for every index, for every node, basically what this is saying is try to use the last node. Try to extend the last node, right? Extend the last node. Or last numbers sum, right? So basically, if using the last number is good, strictly better than whatever is updated, then we just do it. We update the DP. Let me just define this real quick. DP is the length of the longest max array size ending in index I or whatever, right? And previous is the previous I guess I used this or whatever, but previous is the previous index of the last element of the last sum, right? And you kind of see, maybe we don't even need it this way. Maybe this is a little bit whatever, but let's keep it this way now. But yeah, but this is basically extend the last numbers sum, right? So this now is just, yeah, this is the same number because you're just adding this to the last number. and therefore you're updating the previous in this way, because basically, yeah, and basically the idea behind this, the previous, is that the sum, sorry, the last, the best sum ending in this element is going to be prefix of I minus, oh, I guess it's just this formula that I have here. Right, basically the idea here is saying that or is the sum of all numbers between index I and previous of I, something like that, right? Basically this is just saying that your last number is this is the last gap that you have, right? So that everything in between is going to be summed together. Yeah. And yeah, so basically if this is greater, you just take it. Otherwise, if it is the same, then you take the number, you take the index that's to the right. And the reason why we take to the right is just it's greedy, right? Because if it's to the right, that means that the sum is going to be smaller. So that's why I did it this way. And then after that, as we said, this is the last sum. So basically this, what we're doing now is actually doing a push DP. So this is the pull part, but kind of you're pulling from the last last number. But here we're doing a binary search for the next number, and this formula may look a little bit weird, but okay. So that sum is this. Hopefully this makes sense, because this is just the sum of all the numbers between I plus 1 and the previous index that it was pointing at, denoted as the best place to, that gives us the DP sub I, the best max array size, right? So this is the last sum that does that. And then here, prefix sub I is basically, because the prefix array is the prefix sum, right? So if we want to search, so basically we're trying to search the distance such that from here, what is the next index that is last sum, or at least last sum away, right? For example, if last sum is 5, then basically we want to search the and the current total is equal to is equal to 10. If the last sum is 5, then you're trying to find the number that is 5 distances away. So if the current total is 10, then you're searching for a total that is greater than equal to 15, and that's basically what we do here, right? We search an index. That's the case, and yeah. Hopefully this kind of makes sense. This is kind of really hard, to be honest. Yeah. Trying to think whether there's a better way to explain it, but yeah. Basically, if you understand prefix sum, then yeah, the last sum is giving you the last sum that you have to match or bigger, right? Because that's defined in the problem, and the prefix sum is the previous total. So we're trying to get the next number, the next index in which from I plus 1, it's going to be last sum greater than, right? Because then basically what this is saying is that prefix of the new index minus last sum is going to be greater than or equal to prefix of I plus 1, which is what we want, because we basically want the next index in which the current thing can update, right? And this is what we have to update here. It's saying that if this gives us a bigger subarray on that new index, we then update that new index, and that's pretty much it. And then at the end, we return the max of DP, which is actually just the last element, I think, because at worst, this keeps going by 1, but I just kind of wrote it here so I don't have to think about it. That's pretty much the idea about all of this. I know that I'm probably missing a bunch of stuff because this is a very hard problem. Like I said, it took me 2 hours to go to understand it. I mean, I'm not smart, so maybe you could do better a bit. But that's how I kind of be able to talk about it. Yeah, that's pretty much it. There is a way to do it with just pull, by the way, with a deck, and you can do it in linear time. But I'm not gonna go over it. It's late. It's hard. But it's still kind of the same idea though of just finding a chunk in which you can update, and then you same thing as most sliding window problems. But yeah. Uh, the reason why this is hard, I mean, well, there are a lot of reasons why this is hard, but what I was saying about the asymmetry is that so this allows us to push, but the thing is that there's no easy way to do this, or rather, there's no easy way to do this going backwards, creating the edges is doing the pull, and I mean I guess you could like create the edge and then during the pull actually update, but it's the same anyway at that point, right? But if you're looking at it from the pull to calculate the edges, you may not realize that yeah, and I think in this particular thing is that you also remove a lot of edges that are not going to be optimal. That's the other big thing, right? Is that, for example, we have, and that's part of the greedy as well, is that if you have like some numbers like this, then yeah, if you drew a naive edge, you may say that okay, maybe this could be 2, and so so there's an edge between here and here or something like that, right? Because then now you can combine these two to 2 and that creates an edge. But because of the way that we structure the greedy in such a way that we only look at edges that are going to the right, knowing that now we have the best possible thing, this actually eliminates a lot of edges that on the post side would be making it n square. So that's basically the really hard part about this problem, is that if you have to process these greedily in a way such that you eliminate a lot of possible edges, right? Because technically speaking, if you have 2 here, you can also even say that there's an edge going from here to here because you can combine the 2, but obviously also but you can also combine these 3 into a 3, and that's an edge too, right? In the traditional longest path in a DAG, and also these 4 to a 4. But the thing is that we combine 2 things, the push, which we only create 1 version of, but then we also allow it to propagate using this thing, using a little bit of pull. So I don't know. I'm not gonna lie, to be honest. This is one of those problems that for now, in the moment, I understand it. Like you can ask me questions and I'll understand most of it, but I still probably need a lot more practice with respect to being able to solve this live, right? Not this, but like if I were able to, if there was another variation of this problem, a similar but not quite the same, would I be able to do it? I'm not super confident right now, to be frank. So I have to do a little bit more practice as well. But I hope that these ideas, maybe, because the hard part about this is not even the ideas. I think the ideas are fine. Like if you are able to kind of get close to this problem, you probably have a lot of different components like done before, right? Like you know how to push DP maybe, or maybe you know how to do prefix sum, and maybe you know how to do the pull in a effective way. But for this particular problem, it's about putting all those things together, and that's really the hard part. And the linear solution is all the same, except for that it requires a sliding window, which has you have to figure out the invariant of that sliding window, which is, like you're like, sliding window. I know sliding window, but it's still pretty hard. So yeah, there's a lot of things, and all these things, in theory, if you want to be rigorous about it, they also are greedy, or some parts of it are greedy and requires a proof as well. So it's tricky, it's hard. So yeah, let me know in the comments what you think. Let me know if you have any questions. Please, if you have questions, ask the question. Don't say you can explain it more, because that is not useful for anybody. I'm not gonna know what to do with it. I'm just gonna be like, I don't know, watch it again. Yeah, that's all I have for this one. Let me know what you think. And again, you could watch me solve it live during the contest. Actually, after the contest and after some cheating. Now. I feel like this is a known problem, but I don't know it. What is a non-decreasing array? Do they explain it? This is already non-decreasing, right? I don't get what... They don't explain what non-decreasing is. Like they put it in bold as if you should know what that means, but I don't know what that means. They don't... Leetcode. What does non-decreasing mean? I'm gonna get wrong answers because I don't know what non-decreasing means. I think it means no decrease. So it's just like monotonically increasing, right? I mean, that's fine, but they should just say it. Anyway, N is big though. Is it greedy? They really should define the definitions. Is it greedy? I guess so. I mean, if it's greedy, people have gotten it already, right? I don't know that I think it's in greedy. Oh, it's not 10 minutes yet. What is the not greedy case? Would you ever... So you never do the first element, but then you would want to create... Well, unless you want to do all of it. Increasing. What time is it? I don't know. Wow, people are really fast. But no one seems to have gotten Q4 yet, though. Maybe because people also cannot read this forum correctly. I don't know that I am. One person got it, huh? I mean, the DP is n square for sure. What would that look like? So it would be a rolling sum, but then now you have 5 or whatever, right? How would you get it given that? Still only one person, huh? Who is it? Oh, it doesn't say. What is another way of thinking about it? Some sort of greedy heap thing, maybe. How do you change this to so that DP is n squared. What does the DP look like? But it doesn't even. Yeah, that's more than. That's a lot of states, right? We have to do that, and then that. Is there a more greedy thing about heaps? Is this the right answer or the only answer? This is gonna be 8, no, 7, nope. So this is the only answer, right? Is there some sort of sorting that we can do? Well, the smallest number is, let's say this is another 4, right? You wouldn't combine it. I mean, if it's 4, 3, 4, 2, 10, you, I guess you could. That's still, I mean, you definitely need to combine the 2, but I'm not convinced that you want to combine it with the 4. For example, if this is 5, then you would never you would never add it to. No, you could still do it with the 5. Oh yeah, but you would never do it with the 4. But here, if it's 10, then you would never do it with the 10, because there could be a 11 afterwards, right? Then how do you decide which way to go? Is there an exchange argument somewhere? But you do need to combine the 2. Can I subtract stuff? Would that help? It's the only one person getting it. I thought it would be more standard, to be honest. It feels like it's more standard. But all my greedy ideas kind of fail. I'm sure the greedy of just like going left to right fails, otherwise pure web got it. I really am curious what the wrong answer for that would be. Oh, I guess maybe something like this. No, but then I think you just do it anyway. I think that's not a. Then here you have to go back. Otherwise, if you do 2 and 7, you would fail. Is there another way to think of non-decreasing? Is there something with prefix sum? Wow, only one person got it. That's 4, 7, 9. Does that do anything for me? Can I do a binary search on the answer? How would that look like? Is there a possible answer with 3? I mean, if you have to, if greedy works for. TP is 10 to the 5th to the 10 to the 5th, so that doesn't help. I said it wrong, but I don't, I'm not going to correct it, but yeah. So, I mean, there are 2 DPs, but the other one doesn't work either. So this tells us that we're trying to find numbers that are less than half of it. Is that good enough? So that gives us binary search maybe? Or max over the prefix, right? This is 9. Is that true? I don't think that's true. Like 15. 15 we're not searching for 7, that's for sure. The prefix sum, that doesn't make any sense. I don't even have any idea, to be honest. I think that's the hard part. It's not even like I'm grinding it out. I mean, what a unfortunate I didn't get a Q4. Still gonna screenshot it though. But what does not increasing mean? What does sum do to us? And you could have different sum of different components. Like is that true? Is that possible? I think so, but like, for example, you have just like 2, 1, 1, and then like, can there be another number, like, I guess 4, 2, 2, 2, 2. Like here, you want to combine both of these, right? You want to be a 3, it doesn't matter. Is there a binary search? Prefix something. Let's say, okay, let's say 9 we're good, but then the 15, how does this even relate? I guess you don't. I don't think that's a thing. Man, I have no idea. This is wild. I don't even have like a, I mean, yeah, okay, there's some greedy ideas, but clearly it's not working otherwise. People would have gotten it. I am curious about the case. Well, I mean, I have the cases, I guess, but I don't even know. I have some cases, I don't have all the cases. Okay, so the greedy would be take all possible prefix and then greedy the rest. I think that feels alright. And then the question is, can you do it in a smart way? Because that's n square. Can you optimize the shift? Yeah, even if for each number you'll be able to skip to the end. Doesn't help. Okay. Let's say you have a prefix. If you have the prefix or you have the first number, you could greedy the rest. Now, is that a... Is that prefix? Can I do an update in less than O of n time? Wow, a lot of people are not getting it, so I'm not unique at least this time. Can I go backwards? So then one element is possible. Is two possible? Can I do two binary searches? Two is not possible. But 3 could be. So that's not binary searchable, right? Like, you have 2, 4, 7, nope, 5. So 3 is an answer, 1 is an answer, but 2 is not, because the prefix would be 6, 5, and then that's just not possible. No way I'm number 1, because wow, some dude got it. Though somehow it's struggling on the other ones, but good for them. I'm not even sure that's faster. The number of components, prefix, binary search on the prefix sum. I mean, that's fine, but I keep refreshing because I have no idea, to be honest. I'm not like, I don't know. I mean, not that it would give me any idea at this point. I think we all agree that it is pretty hard. But it's still like 53 minutes left. It's not even, it's way, we have time that if I have an idea, I probably could implement it, but I don't even have any ideas to play around with other than the brute force one. Let's wait it out. I think I'm not doing anything with it. Oh. Yeah, wrong way. Just terrible code, but this should work better. But it's n square. I think greedy makes sense if you had the prefix, but Obviously this is n square. So is there a way? Is there a way for me to optimize this? I guess that's the question. I couldn't do it in my head. That's why I typed it out to see if I could visualize this a little differently. But maybe not. I mean, there is this idea of prefix sum, and you can do a binary search for it, but you still do n hops at worst, and that's going to be n squared. You have to be able to reuse work, and I don't know how to reuse work. Do we do it backwards? Does doing it backwards make it better? You have one component, you have two, nope. Three, then can I do it backwards? Let's see. Let's say I have 4, 3, 2, 6, just a random one. So then now we have 15, right? So that's 1, so that's good. And then now we take away 6, so that's 9 and 6. No good, but how do you even check that? Right? Oh, that's prefix of 4. Maybe that's an easier way to write it. And then now prefix of 3. But then now you take away 6, and the prefix of 3 is already no good. But how do you even know? How do you check it in good time? And then next is going to be 7, 7 to 6. Does that help? I mean, you can merge them, but so that's good. And then now, is that true? Oh, but I mean, it is suboptimal, but it's good. And then now 4, right? So then now you have 4, 3, 8, and that doesn't even make sense because then now you have to move to 6. I mean, in theory, you could also do 4, 9, but that's not optimal. You actually want to combine the 6. How do you do it? Right, the cases are weird. Maybe. How do you reuse work? There must be an observation they're missing. Well, that'd be funny if they're using like Java or something crazy. No, 10 to the 5th is pretty big though. You know, they don't do basic things like defining what non-decreasing means. That'd be funny if everyone just misreads the problem as well. Oh. I mean, given a prefix, everything is fixed. But given the same prefix, that means that there's no place for DP because everything is already predetermined. The closest thing you can do is binary search, but maybe there is some like principle about this. Okay, maybe it is just binary search and work. I think it's still maybe too slow, but the idea is that the prefix every time. So let's say you have this as a prefix, only the 4, right? Then it will, at most it's going to be 3, but this number always goes down. Right, so 7. This is at most 2. No, that doesn't make sense because you can have something like 1, 1, 2. No, then it only goes up to 10 to the 5th, right? So in that case, what is 10 to the 5th? I guess maybe binary search. Maybe that is it. 10 to the 5th is what? 100,000? Was that 10 to the 2 to the 16 to the 17? So that means that is that true? I don't know that that's true. Let's say you even need. What is the worst case? Maybe this is the worst case though. Right? And in this case, then it'll be n squared, but by then, because as you with the prefix, four people got it. Good. Ah, congrats. I mean, I think that's the only idea I have, so I'm gonna try for it. What is this? A 7-pointer? Okay, fine. So basically, okay, what does this look like? Okay, J is this part is fine. We want to look for prefix sub I plus 1. This is the sum of the plus last, right? We're gonna bisect left. Okay. Yeah, okay. By definition, it'll be bigger than j plus 1 or I plus 1, though. We can check for it, I guess. Yeah. Okay. So then now, how do I do it? Okay. If index is greater than n, then we break. Otherwise, j is equal to index. I think that's actually it, which is actually a little. Oh, I have to update last. Last is equal to something. What is last equal to? Last is equal to prefix of j minus prefix of I plus 1. J is a little bit weird because j is. Let's make sure that it runs first. It might not. I'm off by 1 and something though, at the very least. Index is the index of the prefix. J. Why? Tell me why. Oh, this doesn't ever end, so that's why. Oh, that's one why. Ooh, n is not the last element, so maybe that does make sense. But okay, you have to prefix the current is 6. So the last number is 3, we know, and J is 3012023. Oh. I am dumb. Wait, what? Current and last is looking for 6. So J is 30123. No, well, it got updated to 6, right? And last is, I need an I. I is 1. Well, last is 3. Okay, so it's 3, 6. Okay, that looks good. But I'm not updating someone correctly. This should be... let's just want to real quick. Is this a J plus 1? Yeah, this doesn't make sense though. Well, this could be the last element, but oh, what I deleted it. So 3 and then it updates to 3. Why? Oh, this isn't I plus 1. This is dumb. This is the last index. So maybe this should be index and this should be J. Larry is not a smart man. Okay. Still error, but maybe slightly better error. Nope. Still pretty bad error. Three and then 3, okay. At least this makes sense. Okay. So index is 3. And the last number is 3, that makes sense. Okay, but then now, oh, I don't put it back. So this is the last number. but now you have to also I don't update current. What am I doing? I'm not doing anything. Current is equal to prefix of index plus slash. At that point it could be J, I guess. 143. Okay. Am I actually right, or am I just lucky? Okay, let's take a look then. Can I count? This might still time out, but I don't have any ideas, so. What is 0? Okay, that makes sense actually. 0, 4, 3. You take the first 3 number, it doesn't actually work. That's true. I mean, okay. Now I just need a really big list, right? I mean, this is fine. Does it time out when, you know? Right? My hope is that it doesn't, but I guess, you know. Oh, that, I mean, okay, prints way too much, so so that factors into the time. Let's run it again without the printing. Still a little bit slower than I would like. The 3 seconds or 1 second each. Depends on the number of cases, but I don't even know that this is the worst case. Try that maybe. Definitely much slower. Oh well, so we're not gonna do this. I mean, it was just an idea because I have no idea. I mean, at this point, 11 people got it right. Good for them. Can I early terminate? Would that help? I don't think so. This is the thing that times out. Definitely if the prefix is more than half, then we can do it, right? So yeah, if current is greater than hash number, then we continue. Fine, right? Does that help anything at all? Nope, still times out for this the big case. That only eliminates like a third of the time or something like this. Right. Well, this would never be true. What do I actually mean? I mean, this is what do I actually mean? No, I mean, I think this is right. I mean, this is a really weird way of writing it, but this is just prefix I plus 1. This is this times 2, right? This still doesn't work. I mean, this shouldn't work anyway. If it randomly works, that'll be funny, but should be faster, but it's really not fast enough. just want some benchmarks. I was hoping that there's some like weird probability in which this would be fast enough, but I mean it is slightly faster. Problem is you can't do binary search, can you? Let's see. Let's see the possible ones. Maybe this would time out just because it prints a lot, right? So a lot of random numbers are possible, but this is definitely doesn't seem binary searchable. What if we do the other one but only once? Let's see if I see a pattern. So that's still not good enough. So that shortcut didn't do anything. Wait, this faster though, but is there any properties that we can abuse? I mean, this feels like a pretty basic case, so I'm not getting that, I'm not getting this, but... Or like, I mean, if it's time limit for this, then this is not submittable. I think there's only like shortcuts. It like it saves one binary search. How do the numbers get merged in a good way? But it's kind of weird that none of the top people finished it, like Ari. Uri, however you say it. Does this mean? Okay, so if it ends here, then otherwise everything is combined afterwards. Otherwise the last number is going to be this is the, what is this again? That's not right. Okay, so if the number ends here, then we have a thing. Otherwise, you do the one in count. D2P, what am I even thinking of? What am I at? What am I doing? Is this max or min? That's basically, this is the yellow try. Was that right? Does this even make sense? Basically, I have 15 minutes. This is the last number, and then now it ends it. So if it ends at here, this would be the thing. This is just the, if you keep adding number from the this doesn't seem right. This is 4. There still needs to be a 4. Maybe that's kind of right. Yeah. Because it needs. No, I mean, is this right? Did I miss the thing? Okay, so this part makes sense. And otherwise, you update the number with, so it's the smallest number. I don't know if he is even right for this one. I think it's just a little bit lucky. A 5, right? I have no idea how to solve this, to be honest. Maybe. I mean, I have 10 minutes. If I didn't get any idea on the first whatever, I'm not going to get it here. Well done, people who got it. Trying to see if I can figure how to do this. Okay, so DP is the maximum number that we've seen, so it's 4. And all this is saying is that it's just merging, right? So am I missing something weird? I mean, I don't think this is right anyway. I think I'm just messing around. Uh, 8 minutes. This is one of those problems that I just have no idea, so I don't even think I'm gonna upsolve it. by like spending another hour. I don't feel like I can figure it out, to be honest. Like some problems you're like, I'm close, I feel like I have some ideas and maybe I could get it, but why is this -6? I mean, it's adding this twice, but it should be -1, right? So, okay, so the numbers is big, then that's good. We have all the previous numbers all together, and this is all the previous numbers all together, right? Otherwise, this is the last number. Otherwise, it remains last number or this thing. I think I'm calculating this thing wrong, maybe. Like it's 2. Did I just get the signs wrong? Doesn't seem to change anything, which is actually kind of weird, but I have no idea how to solve this. I think I'll have to do the cheating route of looking up, see what people do. I don't think I have any idea. What a waste of the first 3 questions. Oh wow, a lot of people. No, maybe not a lot of people, just a lot of people. Actually, I did pretty well in the first 3. I don't know how that happened, but what did people struggle Q2 on? Oh, they didn't recognize. This is actually a tricky one. I could see it. And Q3 is the TP. That's why I got so fast. Unfortunately, not very useful because I didn't get Q4. I wish Q4 was the easier one today, or a standard one maybe. Then I don't know if I would have won, but I would have topped something. Just from having an early time, like it was a template one. Then it would have been very easy. I don't know how to do this. I mean, I tried a few things. I thought maybe I could do DP where DP on the last on the chunk, and then if you don't add a chunk, I think this is just greedy. So I don't know. I think the n square one is correct, but I can optimize it. So I guess I should have saved that code somewhere actually. Oh well, 3 minutes. I think I know that I always say grinding, but grind works if you have some idea. I don't have any idea on this one, so I'm just gonna check. Wow, it's 1 a.m. I forget that what time zone I'm in. It kind of sucks that I forget, but it is what it is. I have no idea, friends. So, I mean, I don't know. Yeah, right now I'm just waiting out the clock. I don't know how to solve this. But yeah, I'm just keeping my thing on so we can see if I can learn together with you. This is why I still have to yeah, I don't know. Of course, feel free to fast forward. I'm just leaving this in because I don't know, just for completeness, and I don't want you to feel like, you know, like suddenly I have a breakthrough and I don't have it recorded or whatever. But I am just I don't know, just being sad. Not that sad. It's okay. I mean, I'm top 20, so how sad can I be? But it just feels like a missed opportunity. Like I guess Q2 was harder than I think. Someone sent me a link to this, so apparently, what's TLDR? Is a segment tree or something? Ah, it's a TCO regional. Don't know. I'm just reading up what the situation is for this one. I don't know. people in my chat is saying that the thing that I did with the binary search should have worked, but I'm not convinced. Or at least, you know, you saw it, so. But I wish I kept a copy of my code. But yeah, I tried prefix sum. Some people are saying that prefix sum works, but maybe not in Python. I don't know. Let's see what we did. This is what we did. We did this. I mean, this may be different from what we did. Yeah, okay, let's see what this is saying. Let's see if I can learn from this. This is clearly not what we did. It is binary search, so I guess I had some idea of it, but you know that's not a useful metric. You can just say every algorithm, right? But also this is a good way to write prefix sum. I gotta remember that. Let's see. I guess it's just reduction. Reduction of this. No, this is what pre-sum dp. I don't know that I can understand this without an actual explanation. Sometimes I try to do it, but this is cool though. I don't. This is kind of what we try to do as well. I don't know if this works. I mean, we didn't do this because, well, I just couldn't. I mean, we were playing around with it. I didn't actually code this up, but yeah. I mean, I guess I could look at C++ as well. I mean, this is the same idea as number one person's same code. Let me maybe I could understand the Java a little bit better. I mean, okay, prefix sum. Okay, got it. DP and index. What does this mean? I mean, I didn't do it this way. Mine was timeout. I'm just chatting on the Discord, but I mean, this is just binary search, but I don't know. Did I get it? I don't get. Okay, so index of I. What is index of I? Index of I is. Good job, remix. On the 12th. Oh, wow. I'm not even top 25. That's sad. 27. Kind of crazy, actually. I beat people by like over a minute and a half on this. Oh. Wow, this is kind of that's sad actually, because he was up for so long. Ah, Chi impact, nice. Oh. How do things keep going down randomly? I don't know how the scoreboard is updating. Either way, good job, Chi. Anyone else to give a shout out? This is a very long video. Sorry, friends. I don't even know if I. Okay, let me actually make. I'm just chatting on my Discord, but let's make an attempt to look. Okay. Okay, maybe not that one though. Okay, I don't know why you have so many spaces, dude. Okay, prefix sum. Get next index. There's some. Okay, let's actually look at this one then. Previous of index is equal to I. This is like some sort of 2 times. If I understand one portion of this, maybe this would be good. I don't even know how this works. Oh, well, this is just a number of things to move by, I think. I see. Okay. I think I understand now. It's just basically, it's almost like a scanning, and I now understand the Q1 too. Yeah. I think I misunderstood what this was before. But basically, I guess we were kind of thinking about it along these ways where we're just I guess I have trouble kind of separating the states. I think that was the problem that I couldn't figure out a little bit. like mm. uh, I'm trying to understand it. Sorry, friends, I'm not speaking too much. This is not an easy problem. I mean, obviously, because otherwise, more than 20 people would have gotten it or whatever it is. I mean, he made it linear, which is ridiculous. I think what I need to do actually is to step through it. I think I don't know that I understand this one without doing that. Yeah. I mean, I don't have any. Oops. Don't have any code written anyway. So let's see if I understand this. Okay. So I mean, okay. I need to do this though. The prefix sum. Okay. Right. So start. DQ is just a deck. Okay. All right. Let's see it. All right. So this is the before and after, right? $1.9. Okay. Was I doing this? Okay, I mean, okay, this update, okay, so DP contains the biggest number and the last sum contains, what does this mean though? So, okay, I mean, okay, so I think this is the critical step of understanding because, so then now, this is pretty cool though, but I mean, I wasn't going to, but okay. So what does DQ mean? Okay, let's actually print DQ as well. And I suspect that the binary searches is just a variation of this. Okay, so here it stores 1 and then 2 for the first 2 numbers, and then now it removes this. Okay, why does it remove this? It removes, basically it's saying last sum of the oh, and this stores the last sum, stores the index. Is that true? This doesn't look very indexy. Oh no, it's last sum of the index of the last sum. So okay, so it's either 7, and then if you pop, then it's just if you pop an element off. I mean, I guess I get it now, but I mean, I would have wrote this differently, but that's fine because I just used a deck with multiple things, right? With a tuple on a deck instead, but I think this also works. Though maybe not. Maybe the way that they wrote it is because of that, but. This is basically now I'm trying to see it in my head where I can reformulate this and write it without further looking at the code. So basically the idea is that now you have this sliding window, and everything inside the window is the last number that you have to beat, right? I don't know how this works. And basically, yeah. Oh, no. It's not the last number that you have to. I mean, okay. I'm trying to formulate it in my head independently. That's what I'm trying to do. I mean, it's been 20 minutes, so I find that this video is so slow. So yeah. Yeah, this number is just a sum that's in it, but if it pops, is this you? What is this? This is so hard. I think this part I get. This is straightforward-ish. This part I don't have to kind of really understand it. Why is it not the other way around? Oh no, basically it's saying, okay. Let's play around with a slightly bigger example. I think that'll be, though I don't know the answer for it, so maybe it's not as helpful. So just erase these. I think I get somewhat. But yeah, this basically creates a mono stack, the DQ. I think maybe that's why people binary search on it. I think understanding this will make it slightly easier to understand. Okay, so this is 2, the same one, and then now the 2. I guess that doesn't change me. This is terrible. I put a terrible test case. This is a terrible test case. But 5 of some 5. I mean, that's kind of what we're talking about and trying to reuse the logic, the thing as much as possible. And I guess in a way I was thinking about this, but I couldn't make the final leap. No, that's not true. I did it a different way. This number's only... I didn't expect that this to be monotonically increasing though, to be honest. No, I guess that makes sense. Because if you give it a new number, at worst you just combine it with the last biggest number, right? And by definition, okay. So basically, okay, let me rethink this a little bit. So let's say you have... Okay, let's say I have the logic of, okay, you know, maybe we move around some stuff around so that's a little bit dumber. Okay. Okay, so let's say, okay, rep 1 for 1, and then 2 for 2, and then now 1, what do we do? Well, at first we just combine it with the 2, so this is 2, yeah, 1, 2, and then this should be 3, right? If that's the last number in that case. Here's a 5. 5 is good, and the last number is a 5. That's fine. Right, and then 4. I guess 4 will have to combine with the 5 to make 9. Yeah, I guess that's the only way. But then now the 1 is interesting, right? Now 1 we could combine it with the 4. So we definitely, yeah, we do that, but it cascades stuff, right? Because this could be now 1, 3, 5, 5. So how does that work? So this means that this is now 5 as the last number, but this can only be if I guess that's the thing, right? Then how do you cascade this out? So this 5 comes out of the 9. Let me see what happens here. Okay. 2 is 3, 3 is 5, 3 is 9, then 4 is 5. So this is actually, this is what I'm saying, but how do you, the deck is just, this deck is actually not what I thought it would be. Oh, the deck is an index, so I think the 5 is right. So 0, 1, 2, 3, 4, 5. So this is just a 9. This is a weird deck, actually. So the deck is all the indexes of the biggest sum, which is the last sum, right? So if you take it out, but how can you know how to take it out? Like, what if like, how do we? So we add the. So. Huh. I mean, 6 is the biggest number, but I don't know how this works. I mean, basically, I know that there's some concept about just building like jump pointers, kind of. But how? Tell me how. If you keep pinging me on my Discord, I don't know what it. Okay, so maybe I'm reading that wrong. So okay, 4, 5 is the numbers in 9. Oh yeah, that's right. I'm reading that wrong. Okay, I am dumb. So no, is it the 4? No. Yeah, I'm reading this wrong. So 9 at the end of this, the total sum becomes 4, 5, and then the next number is. And then we just ask ourselves, is the next number big enough that I can, okay, right, because that's what this is doing. Well, this is very hard to read, but it's basically saying, yeah, because basically this number is the last sum plus this number. So then the new number. This is kind of confusing, actually, is it? No, I see. This is basically. Okay, so this is prefix sum up to that point, and then the last sum at that index is all the points up to. Is the stuff that I mean, this part is straightforward. It's just consuming to the left. Trying to find the but this part maybe I'll take a look at the binary search one. No, I mean, it's the same idea. It's just try to figure out the last place that you can go. But I don't know that I understand it. Okay, so let's say this is 4 and we have a 5, right? I mean, if you build the table correctly, I think that makes sense. So then now you binary search how much to do this, right? How much to go left. And then, okay, I think I have the idea. But I mean, I think, I don't know the Q one, but I think, whoops. Okay, I think the binary, I think the binary search makes sense. Okay, I see now. I think I didn't get the binary search for a while, but okay. Let me try to learn this thing. As you go to what's it? Accumulate nums before 0, 0. Is that it? Double check. What's it called? What is the? I'm trying to learn it, but the tools that accumulate, and it's giving me Japanese initial. Okay, it's giving me Japanese Python PyDocs or whatever it's called because I am in Japan. Thanks, but you I have language set on my browser for a reason. You don't have to geocode my thing to give me a language. Okay, so that makes okay, and then now, so we have two things, right? So we have maybe n+1. I don't know. And then the total at that point, right? Oh, this is the last sum. Maybe just call it that. And then now, now what do we do? So let's say this is the number we want. This is hard to set up, but okay, right. So dp sub +1 is equal to just do this for now, and then we want to binary search the length of the last segment, right? So that's not true. Oh, that's the segment length, I guess, but okay, so to I maybe of the prefix. Okay, fine. And then right, where does it go? So then now, what is mid? Mid is the index Okay, so then now this new sum is going to be prefix sub mid plus my prefix sub I plus 1 minus this. So it's mid to I inclusive. That's the sum, right? So that's the last sum, possibly. And then we compare it to the last sum, which is, if mid, then it's going to be last sum of mid. Something like this. Maybe mid plus 1. If mid is equal to right. Maybe just mid, I think. So if this is bigger than that, or equal to, then this is good, and we try something smaller, right? And smaller means going to the right, so left is equal to mid, else right is equal to mid minus 1, okay. And then now we want the last sum. Is equal to prefix of I plus 1 minus prefix of left, that's last thing, and then dp of I plus 1 is equal to dp sub I, unless it is bigger than the last one, right? Or maybe just do this plus 1 as the thing. But maybe something like this. I don't know. I mean, this may just be lucky, so I don't even know if this is right. Let's give a submit. Yeah, I wasn't that confident about it. Or I mean, I thought maybe it's right, but want to double. I mean, maybe there's some like off by 1 indexy things. I think we're probably close, but there's something this part feels sketch to me. That's why. But maybe not. I don't know. Okay, 1. Okay, that's good. 2 is okay. That makes sense. 3. Okay, converge 2. This is 2. Okay, that's good. 183. So that is going to be what? I guess 718. So 3. That's good. Last sum is wrong, isn't it? Okay, because this thing is not binary searchable anymore, which is why this is wrong. How do I do it then? So 886. How do I get 718? Because it is looking up 1168 is why. Which is kind of related to why I didn't feel like, because this does not seem I mean, this probably matches the Q version, but maybe not the binary search version. Maybe the binary search version is a little bit different. But okay, so 2, right? So if this has 2 numbers as 900, it's still smaller. So it probably is Yeah, it probably is just combining these three. Because the last sum here is too low. Or too high, right? Or whatever it is. How do I do it? Condition is a little bit wrong. Because last sum is not monotonic. And this is taking a long time. I have to wake up early tomorrow. I thought this would be right, but I think this is a good test case for it being wrong. Let me cheat again. That one is just ridiculous. Nope, a different one. I mean, this is kind of what I have, so. I mean, they're doing it the other way, but I think it should be right. Oh. People doing, just give me the binary search version. Why is everyone? That's what I was saying about doing, but they're doing it with queues. Maybe, well. Maybe my understanding is still off. I don't know that I understand this formula. I've seen it a few times. I guess doing a separate array is probably more sensible than what I did, I think. But what is this thing? I'm not saying these people do it intentionally or whatever, because for contests it doesn't make sense to write it cleanly anyway. But that's why when you talk about readable code, this is a core part of stuff like that. Is that like this formula is one more step, but I've seen it this way too. But this is, what is this? This is just like the indexing. What is P again? P is prefix. So 2 times the prefix. Well, I mean, this is just I don't know. I'm trying to understand, or try to see, know if I can understand this. I guess this is the DP. I mean, this DP we knew how to do, but obviously it is too slow. Too many possible sums. There are a couple of DPs actually, but maybe should I win out the DP? Would that have helped? Well, this doesn't have to be default take, does it? I understand the linear one, but I don't know that I understand the binary search one. I thought it would be the same idea, but apparently I was wrong. And this guy is using sig tree. I'm not gonna look at it. I click on the same guy again. Maybe, I don't know. I don't know, friends. I thought, this is just a sum minus the last. Maybe this part is wrong for me. Well, the I part is right, but I guess I see. I think I'm just doing this in a weird order. That's why, because I'm doing it backwards, one number at a time. Because I got the other thing. What I need to do is actually look forward, right? What does it look like when I look forward? Say this is the sum, then yeah, okay. I think I get it. Well, I don't know if I do. We'll see. I feel like I've said that a few times. Okay. So then now, let's say we calculate. So it is greedy in the sense that if you have a bigger sequence, then that's good, right? So okay, maybe. Hmm. How do I kick it off? The dp sub I is equal to dp of I minus 1 at worst, right? Okay, let's just write it out real quick. Right, and then dp of sum of 1 is equal to num sub 1, and then now what? And then now we have to do a binary search on this, right? I think we don't need the last sum anymore in that case. In that case, we have a previous index instead. So then now all the DPs could be 1 and the previous is 0. Maybe that's fine, right? And then now the last sum is going to be previous of I, or previous of I plus 1 is the previous index that we sum from, and then so yeah, so we have prefix of prefix of I minus this, that's going to be the last sum that we're working with, and then we do a binary search for it, right? We have bisect left, a prefix of this number. Okay, let's just do last sum is equal to this, right? Last sum plus plus prefix I, right? Maybe. And that's how you get the 2 times this minus this thing that people get. And okay, let's just call this index. And then now dp of index is equal to max of dp of or from here plus 1, because we added it from the previous one. Yeah, maybe I don't know how people wrote it, but it's someone like this, right? Then and then now you could write the previous index is equal to I. This is prefix of I plus 1. Yeah. Plus 1, right? I think that's it. Maybe. Oh, I guess dp index is probably off. Oh, wait, no, this is right. I think maybe this is. Did I mess this up? No. I mean, yes, but same way. What is this index? Oh, right. So that means that if Well, that's not good. But okay, so this is web 2. That's not true, right? We bisect. Oh, maybe this is +1. Maybe. Okay, so that's good. This is good as well. This is good. We just have to return the right answer. Why is this answer not right? Max of DP. Oh, because of this thing. Okay. I should return -1 instead of 0. That's less confusing. But okay. Why am I getting it wrong? Well, this one is still wrong though. Right, so 1, 1, 2. Basically, this is, and this we do this. This we update this to be 2, right? No, we update that. We have to add these things. So we update this one to 2. Well, no, wait. 1, yeah, okay. 2, okay, that makes sense actually. 1, okay, that actually makes sense as well, I think. And then 3. 3 is fine, probably, I think. Because 600 updates it to here. So 3 with the index being 2. Yeah, that makes sense. But then the A66 stop me. Ooh, because we have to do something about. Well, this index thing, right? Let's see. Okay, so okay, so it's doing 0, 1, 2. That makes sense. And then now it's updating 6. Oh, I see. So then it just doesn't update, right? I guess. Because it's not updating to the last element. Okay. I think I just didn't understand that base case well enough. Okay. Looks okay. Let's give it a submit. Oof. A different one. Huh. Okay, I should get 4, I get 3. Okay, 0. We update 2, okay, that's fine. Let me also just print the nums. This is a hard problem, obviously. 82, okay, that's a 2, that's good. And this, if this is the last number, you have to update it to here, so that's 3 and that's 2, that's fine. And then now this is a 1. If yeah, 3, you have these 3 numbers, I think, which is what, 896, I guess. That's good, but that's only 2, so it does not update. And now here, 925, 0, 1, 2. Why is this 1,000 and oh, because it so because it's 1, 2, 3, this best answer is going to be 3, and it's updating it with 3, but the answer is 4 because you can combine these two. Man, I maybe I just don't know how to do this binary search. I mean, that's why I didn't come up with this one, I think, because I think this one I would have got if this was the case, but here, update the thing to, how do you add these then? This one, if the biggest number is 272, then yeah, that's here. You want the biggest number to be 600 to be searching, but man, I still don't understand Q4. Alright, I have to cheat again. I thought I understood it, but I don't. This is way queen. Oh wait, no, that's because half the code is in a weird place. Keep looking at the same one. The same confusion. Oh, wait. If this is this, oh, I have to do the same link thing. I think that's why as well. Does that fix it? Nope. I don't think it would fix that, but it is something that we had to do anyway. I guess in this case, actually, I could just reduce it to that bit. Still missing a little bit. Huh. This code is so short. Well, that's the minimum sum, I guess. I thought that, maybe I'm just mixing ideas. Okay, on I. sum sub x is greater than or equal to sum sub I plus tail. I mean, that makes sense. But I thought we did this. I mean, well, this part is just what we have here. I mean, I keep it using the previous index, but it is the same idea. How does their work and mine doesn't? Because this is what we had before, right? Huh. Am I missing something silly? I don't think so. Or at least, like, I don't think I'm trying to think whether my implementation was wrong or something. But when would you update this 277 to update these to sum? I don't get it. Well, he does 2 updates. I see. So it updates this to I mean, he does that, but I mean, fine, we could write it out, but right? Does that fix things? It does? Wow. Why? Tell me how. Oh, this thing. Because it was at 1, so it was. Wow. I did get this part before. How does that work? It's just basically saying, okay, the best route ending here combines. Okay, wow, how did I miss that? That is so silly. Okay, that makes sense. Oh no. This is not a happy day. Expect answers 2. Okay. I mean, you have to add or 3. Okay. Two, 1. Still 2. We combined it with this one. That's fine. I mean, that is true. And then 3 because 3. The previous is wrong. It's I see. Yeah, whoops. Yeah, okay. See, when you actually understand your code, it's easy to debug. Okay. I mean, that's with, ugh. Wow. Alright, well, I've been debugging a lot, but this one is going to be a little bit harder. Why? Did I miss some silliness here? Oh, I see. Because of the equal, right? So, if they equal, then I think this also is true. Oh, nope. If they equal, then we want to get the smallest sum. That means the max of this, something like that. Again, once you actually understand the code, I think it's not that bad. But to debug, right? Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem, today's contest, everything in between. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.